Hello everyone. So today we will be discussing a very interesting problem, which is nothing but we have to remove duplicate element from a sorted array. So let's take an example to understand this problem so easy. Suppose we have given an array and that array looks like this: 10, 20, 20, 30, 30, 30. So we got total 6 elements in this array. Okay. So what we need to do, we need to make it 20, 20, 30, where size is equal to 3. Now the examiner, so 20 is repeating, 30 is repeating, but these 3 elements are non-repeating. Okay. Now the examiner puts a restriction over here. What that restrictions are, they are saying the time complexity of this problem should be big O of n, and the space complexity of this problem will be constant time, that means O1. Now, if we want to solve this problem, what could be the idea? Let's try to understand the logic first. So let's use a different color. So initially, what we can do, we can put a pointer over here, P1, and we can put a pointer over here, P2. And we can compare the value of P1 and P2, right? In this value. Are they different? Yes, they are different. So we can say, like, if array P1 is not equal to array P2, then what we can say? Then we can say, at least if we kept our size is initially 1, size of 1 means this is something which is referring to an array which is having only one element, and that is basically, if you are having one element, that is a distinct element. So size is going to be 1. So in this case, if they are not equal, then we got an array which is having a different size. So size plus plus. We are doing size plus plus. So that means every time we are incrementing our size. Now, in this case, actually, what is going to happen, we have to understand that, and that is, we can, if we are having same elements, sorry, different elements, we can also say, like, ARR P1 is going to be ARR P2, and we have to increment P1 and P2 both pointers. So we are doing these things because these arrays are sorted, and we are checking this element with the previous element. As this is sorted, if they are having equal, like in this example, if the P2 is in this case and P1 in this case, that means what is happening? That they are equal. So it is not going to enter in this section, in this code, in this piece of code. So what is going to happen? The size is not going to be incremented, right? Because it is a repetitive element, right? So it is not something which is duplicating. But in this case, it is duplicating. If your P2 is over here and P1 over here, it is something which is not duplicated. It is something which is distinct. So your size is going to be different, right? So in that case also, we want, like, this 30 should be here, this 30 should be here. So that's why this line comes. That whenever we are having 10, 20, 20, 30, then it should be like 10, 20, 30, 30. So in this way, we can make sure, like, the first of the portion of the array is going to be very much sorted. Now, what is the length of this portion? Not only sorted, it is going to have a distinct element. Now, what is the length of this? That is going to be determined this size parameter. So let's write the code and try to understand. To write the code, I'm using a different color. So for an example, we are having something called integer race is equal to 1. So this is one pointer actually we are using over here to address our array. Now we are having a for loop. Say, for example, integer I is equal to 1, I less than n, and I plus plus. Okay. And we want to do everything within this for loop. Fine. So in this for loop, we need a pointer wala stuff. which will say that array of this should not equal to the next element. So how we can put over here, that we need to understand. And we need to also do size plus plus. So now if RES ultimately also talks about array size or the array size of the array who are having distinct elements, then we can say this plus plus. See, that is true. And if we are allowing this result value to take the responsibility of size of the array also, then whenever there is one element, then that element should be the case, or whenever, I mean, you can say like the size needs to be deducted, right? Because it is incremented over here. So that means result minus 1, we can say easily. We are reducting this result by -1, and we are putting I over here and allowing I to start from 1 to n. So definitely here, what we can do is error results is equal to error I. So let's make a dry run. Suppose we are having the same array 10, 20, 20, 30, 30, 30. Fine. So let's make a table first. Okay. So find first I is equal to 1. Good. Then we are having result value, initial result value. Then we are doing some comparison. Okay. Now, then we are calculating again the result value, and then we are finally having this array. So initially I is equal to, when I is equal to 1, result is equal to 1. The comparison is basically done between 10 and 20, which is true. Okay. Sorry, true. Result is going to be 2 because the result is going to be incremented. And what is the array value? 10, 20, 20, because error result is having array I values. So error I means 1, result is also 1. So 10, 20, 20, 30, 30, 30, the way array was looking initially, it is going to be same. Now, in the next case, the I value is going to be 2, the result value initially is going to be 1. So the comparison is going to be done with 10 and 0, right? Because I has, sorry, result value is basically 2. Sorry, extremely sorry. Result value has been changed. So result value is 2. So the comparison is going to be done between 2 and 1 because I is equal to 2, and the comparison is going to be done error res minus error 1. So basically this is the 0, this is 1, this is 2. So the comparison is going to occur between these two elements, which are equal basically. So the comparison result is basically false because we are comparison 0, 1, 2, 2th element to 1th element. So the result is not going to change over here. The result will remain same and the array will also look same. Now, when we are having I value as 3, then the result value, what is the result value? Result value is also 2. So we are just putting here 2, right? And initial result value, this is initial result value. Now the comparison is going to occur between 0, 1, 2, 3. So here, that means one pointer will lie over here. So I'm just using a different color. Otherwise it is going to be so messy. So one pointer will remain here. And another pointer is result minus 1. Result is basically 2. Result minus 1 means this. So 30 and 20, there will be a comparison between 30 and 20. And in that case, the result is basically true. And our result value is going to be incremented in 3. So the latest array looks like 10, 20. And you will be swapping between 30 and 20. Because not swapping, extremely sorry, we'll be updating this 20 with 30. So it is going to be 30, and it is going to be 30, it is going to be 30, and there will be another 30. So these 3 30s were earlier there. 120 has been updated with 30 only. Okay. So that is one case. Now the next case, I is equal to 4. When I is equal to 4, our result value is basically 3 because the result value has been updated to 3. So there will be a comparison between, and when we will be doing the comparison, we will see the latest array. So the latest array or last updated array looks like this. So the comparison will be with I is equal to 4. That means 0, 1, 2, 3, 4. So here with I is equal to 2, 0, 1, 2. So these two elements are same. So the comparison result is basically false. Hence, our result is not going to be updated. So it is going to be 2 and the array will look like same. Next is I is equal to 5. When I is equal to 5, our result value looks like 3 and the pointer is pointing over here, and 3 minus 1, that means 2. So this is the 2. So the comparison is going to happen with this and this. And that is also telling a false result. So no updation on 3. So looks like 10, 20, 30 and 330s after that. So this is the important thing. So we will be returning size as 3 because the final value of result is 3, right? So we will, if you just see the code, I have already written the code for you. So remove duplicators. It is taking an array, and this is the result index. There is another responsibility. This is basically providing size. So this method returning the size of the array which is having distinct elements. What is the requirement of that size? Because we will be doing another for loop while we will be printing the array till that element, till that index where the uniqueness occurs. So that's the idea. So if you just run it, you can see like the same value I have given 10, 20, 30. Now if you just make any change on here, say for example, you go 90. So your program looks like, see, 10, 20, 30, 90, 30. So this is something which is very important. Okay, so that's it, guys. If you have any question, you can raise me. Thanks.